Up YouTube, welcome back to my channel with Ms. V. If you're here, it's because you need some help with math, and I am 100% here to provide this help to you. And thank you so much for tuning in. So today what we're going to be discussing is different angles that are formed when parallel lines are cut by a transversal and how to find these different angle measurements. So last video, I talked about parallel lines being cut by a transversal and all the different kinds of angles that are formed. I talked about the congruent angles and the supplementary ones. So if you didn't get a chance to see that video, go ahead and go back to that and watch that video because it's going to make this video a lot easier to understand. Because in this video, I am basically going to just do examples for you guys. So let's get into it. So parallel lines cut by a transversal, and we're doing examples today. So let's go ahead and draw that out. As you guys know, parallel lines are two lines that do not touch or do not intersect. And a transversal, which is that pink line that I just drew right now, is pretty much just a line cutting through parallel lines. Okay, so let's say, for example, and let's make this an easy example. So example number one, let's make this one pretty easy. So let's say that this angle over here is, let's do 40 degrees, okay? Let's say that angle is 40 degrees. And I said, hey, find this angle over here, X, and tell me the measure of X, okay? So the first thing that you want to do for a problem like this is you could go around and figure out what the other angles are. Like, for example, you can find this angle over here because you know that this is a line and you have two angles together. So this is called the linear pair. So theoretically speaking, you could find this angle and then you can basically find this one and then this one and then this one. And then you can kind of see, well, these four look kind of the same as these four. So this one's probably whatever measure corresponds to it, okay? Or you could notice the relationship between angle X and 40 degrees. So notice that they are on opposite sides of the transversal. So one is on the left side, the other is on the right side, which means that they are alternating or they're on alternate sides. And they're also outside of those parallel lines. So these are alternate exterior angles, which based on our last video, we know that alternate exterior angles are congruent, okay? So just by knowing what alternate exterior angles are and by knowing that they're congruent, right away I can say, well, those are alternate exterior angles. So that means that X has to be 40 degrees, okay? Very simple example. That one is not too hard. So now let's take a look and let's make it a little bit harder. So let's do like a level 2 example, okay? So again, I'm going to draw my parallel lines. And I'm going to cut them by a transversal. Okay. And now, again, let me say that that angle is 40 degrees because why not? And I'm going to say, okay, well, find this angle for me. And that angle measures 2x plus 2, okay? Solve for x. That is our objective here, is to solve for x, okay? Now, for these angles, it's a little bit different because this right here, we know that this angle and this one, those were alternate exterior angles, but now this angle is no longer outside of the parallel lines, it's inside. And you can't have alternate exterior interior angles. That's not a thing. They're either inside of the parallel lines or they're outside of them. So in this case, what we can do is, well, okay, I know that this angle over here and this one down here are alternate exterior angles. So I know those two are going to be congruent, okay? Another thing you can notice, if you didn't notice those, you can say, well, this angle over here, it looks like it's just been shifted down here, right? So this angle is also going to be 40 degrees. Those are called corresponding angles because they basically correspond to the same place, okay? So two different ways to do that. And then from there, you're like, oh, okay, now these two angles are side to side. They're adjacent angles and they form the line here, the white line, which means that they have to be supplementary. So the two angles are supplementary, which we know means that when I add them together, it's going to equal 180 degrees. Okay, so they're supplementary. So 2x plus 2 degrees plus 40 degrees is going to equal 180. Okay. And now from here, we just do a little bit of algebra. So we have 2x. You can take the parentheses off at this point, and I'm just turn it into an algebraic equation. So 2x plus 2 plus 40 equals 180. Remember, when we have this, we're going to combine our like terms. So our like terms, these are our whole numbers here, 2 and 40. So if I combine those two, I have 2x plus 42 equals 180. Remember, for an equation, we're trying to solve for x here. So what I like to tell my kids is, okay, if you're trying to solve for x, just put whatever x is in a box, leave it alone. Don't mess with that yet. Anything that is outside of the box, you got to get rid of that first, okay? So we got to get rid of this positive 42. The only way to cancel out a positive is with a negative. So I have to subtract 42 in order to cancel it out there. And since it's an equation, you can think of an equation kind of like a seesaw. So if I take something off of this side of the seesaw, in order to balance it out again, I got to take some more weight off of this side. Okay. So I took 42 off of this side. Now I got to take 42 off of the other side of the seesaw. Okay. And from there, now I have 2x equal to 180 minus 42. 180 minus 40 is 140. So this is going to be 138. Okay. And then now, again, remember to cancel things out. You always have to do the opposite operation. So in this case, I have 2 times x equal to 138. So to cancel out that 2 in front of the x so that I can get rid of it, I have 2 times x. In order to get rid of times, I need to do the opposite. So I have to divide both sides by 2. Okay. And then x equals 138 divided by 2. Which is a number. Let's see, 130 divided by 2 is 75. So 138 divided by 2, it's going to be, sorry, it's not 75, it's 65. So it's going to be 69, okay? It's been a long day, y'all. Don't judge me and my lack of not knowing what 138 divided by 2 is for right now. So x is 69 degrees, which means that that angle, if I want to solve for that angle was 2x plus 2. We know that x equals 69 degrees. 69, sorry. So now from there, all I have to do is plug in 69 for x. Okay. And 69 times 2 is 138 plus 2, which is 140. Okay. And that's pretty much it. Another thing you could have done here is you could have said, well, I know this angle is 40 and I know these two are going to be supplementary. So 2x plus 2 has to equal whatever 180 minus 40 is, which is 140. Okay. So you would have known that this angle is 140 and then you would have solved for x that way. So there's a lot of different ways to do these problems. I don't like to restrict my students to just one way or another way. Okay. So let's look at one more example. So example number 3. And let's see if I can make this one a little bit more complicated. So these examples, they're not too hard. So the geometry part is honestly just figuring out what the angles are and what the relationship is between them. After that, it's all algebra. So notice here, like in the last example, I did straight up algebra there after I figured out, well, okay, those two angles are supplementary. So like I said, we can have more than one transversal. So I guess I'll add another transversal on here. I did not think it was going to erase my whole entire line. All right. Dun, dun, dun. All right, so let's add another transversal right over here. And notice those transversals are also parallel to each other. You could have transversals that intersect, but I think that's getting a little bit too complex, so we're not going to do that. So let's do 30 degrees over here. And let's solve for x over here. Let's solve for y over here. And let's do 2z plus 1 over here. Sorry about the barking, y'all. Those are my dogs. All right. So again, There's two transversals here, but that's okay. The good thing is that these transversals are parallel to each other as well, so they're not going to affect the answer here. So we can start off by noticing this is 30 degrees, which means this angle over here, which is the corresponding angle, instead of going up or down. So in my last video, I said, hey, you have corresponding angles. All you have to do is slide either up or down or side to side. And then I kind of paused and I said, oh, it only depends if you have more than one transversal. So this is one of those cases where we have a second transversal. So I can also slide this way. And this angle over here is a corresponding angle. So this over here is 30 degrees, which means that this angle is 30 because they're vertical angles, okay? Which means that X has to be 30 because those are alternate interior angles, okay? So again, starting here, this is what we were given. I knew this was 30 because they were corresponding, boom. I knew this was 30 because they were vertical, boom. I knew this was 30 because they were alternate interior angles, boom. You could have also said this is 30. Oh, this is the corresponding angle. So it also has to be 30, okay? So the most important thing here is to know your definitions, because once you know your definitions, it just makes life so simple, okay? And now we're kind of in the same situation where we have a linear pair. So it's kind of like example number 2. So 2z plus 1 plus 30 equals 180. And again, if you want to, you can just do 2z plus 1, subtract 30 from both sides, which is essentially what I had mentioned doing in the previous example if you wanted to do that. And you end up with 2z plus 1 equal to 150. And now from here, we just solve for z. So subtract 1. You could also combine the like terms. I'm just showing you guys a different way to do this. And then now this is 149. And this is not going to be a pretty number for z because now we have to divide both sides by 2. So z equals 149 over 2, which is going to be a decimal, 74.5. But that's okay because remember, z is not the measure of the angle. Z is this. This whole angle measures 150 degrees, okay? All right. And then now we're just missing y. Dun, dun, dun. All right, so this angle over here is 150 because they're vertical. This angle over here is 150 because these are corresponding, which means that y is going to be 150 because they are corresponding, these two right here, okay? So slightly more complicated example, but not really. You just need to know the definition. Same thing as always. And just do a little bit of algebra to find z there. But other than that, this is pretty much how we decipher or figure out the different angle measurements when we have parallel lines cut by a transversal. So if you guys enjoyed this video and it helped you, especially with the algebra part, please give me a thumbs up and subscribe to my channel so I can keep posting more videos for you guys and I can do them more frequently. And I will see you guys in another video. Bye, y'all.